Well, welcome. I am Mr. Murphy, and in this particular video, we're going to be looking at Power Standard Skill number 28. And this is actually a continuation of a video that would have started out this standard, or maybe you're watching this one first. But for this particular skill, we're going to be looking at it in two parts. In this video, we're going to be looking at how to solve a right triangle if we're given two sides. In the previous video, we saw how to solve a triangle if we're given one side and one angle. So this one's going to be very similar. There's just going to be some different parts to it as far as how we're going to start the problem out. But we're still going to be using those same trigonometric ratios, and we'll be talking about those in a minute. Let's first take a minute to look at an example that you'll be working on here. This is an example of a right triangle where we're given only two sides, and we'd be looking for in order to solve this triangle, I'd want to find out the measures of the other two angles, angle B, and how to find that measure of the hypotenuse. So that's what we're going to be looking at. But first, let's talk about those trigonometric ratios again. And you want to recall that we have this phrase, SOHCAHTOA, to help us remember these ratios and to keep them straight. But remember, the sine of an angle is found by the ratio comparing the opposite leg divided by the hypotenuse. The cosine is a ratio of the adjacent leg divided by the hypotenuse. And the tangent is looking at the the opposite leg divided by the adjacent leg. And just to recall the parts of a triangle, remember the hypotenuse is always the side across from the right angle because it is the longest side. And the adjacent leg and the opposite leg all depend on what angle we're looking at. So if we're looking at angle theta, which is down in this top example here, and it's in that bottom left-hand corner, then the side across from it is going to be the shorter leg, the opposite leg, and the adjacent leg would be the side that, in addition to the hypotenuse, that makes up that angle. Where if the angle now is flipped to be on the angle theta is at the top of the triangle, now the opposite leg would be at the bottom of the triangle, and the adjacent leg then again would be the side that makes up that angle. Well, today we're going to be looking at, in this video, again, if we're just given two sides, we're not going to be given any angles with the exception of the right angle. Well, we have to know how to figure out the measure of an angle here because it's not as simple as the previous video as just starting out and finding the other angle by subtracting it from 90 because we don't have an angle to work with. So we're going to have to know this rule of how to use trigonometric ratios to find angle measures. So let's say, for example, I'm given the sine of an angle, or I'm looking for the sine of an angle, and I know that it's equal to some value. Well, this rule here says that for any angle between 0 degrees and 90 degrees, the inverse sine of that angle is equal to the angle, the theta. So in other words, the inverse sine undoes the sine. And that's how we're going to use it. So let's say if I have what's in blue here, the sine of an angle equals 7/15. And I want to figure out what measure of an angle would give me that ratio of 7 divided by 15. Well, using that rule, I could take the inverse sine of both sides, and that would give me my angle would equal the inverse sine of 7 divided by 15. And on your calculator, you're going to have to access that by using either the control or shift button, depending on your calculator. And above the sign, you'd see that you have a sign to the negative first power, which means it's the inverse sine. And so you would access that and take 7 divided by 15. It'd give you the degree measure of 27.82. Or you could round that to the nearest degree and say it'd be 28 degrees. So let's look at some examples now together where we're going to use this. So looking at this one here, this is one that we saw earlier. This is going to be the triangle where we're going to take these two sides that we're given, the sides 10 and 6, and we're going to use this to find the measure of the hypotenuse as well as those two angle measures. But let's actually start with those two angles. Now, to find the measures of those angles, which would be angle A and angle B, we could find angle A. Let's say if we wanted to start by finding that one. What we want to do is we want to see, well, how do these two sides relate to that angle? Well, this side here, that's length 6, that would be side A. That's opposite that angle. And this side here isn't the hypotenuse, so this would be the leg that's adjacent to that angle. So what ratio uses the opposite and adjacent? Well, that's going to be the tangent, because remember TOA. So we're going to take the tangent of angle A. I'm just going to write this as A. The tangent of A equals the opposite, which is 6, divided by the adjacent, which is 10. So with that rule, to find the measure of angle A, I'm going to take the inverse tangent of both sides, giving me the inverse angle A is going to be the inverse tangent of 6 divided by 10. And if you do that on your calculator, you're going to get approximately 31 degrees. So just like we did yesterday, or in the previous video, if I subtract 31 from 90 to get the measure of my other angle, I get 59 degrees as my answer for my other angle there. Now, I also have to figure out what side C is. So to figure out the length of side C, here's what we're going to do for that. Well, there's a couple ways we could do it. I'm going to show you a way that we could use the Pythagorean theorem. So remember, the Pythagorean theorem is a squared plus b squared equals c squared. Well, side A and B are the two sides I'm given. So I'm going to use side A as 6 squared, or side A would be 6, so it would be 6 squared. Side B is 10, so we'll have 10 squared equals c squared. Well, 6 squared is 36, 10 squared is 100, so we have 136 equals c squared. So to find out what c is, I take the square root of 136, and that gives me 11.7 as my answer. So side C would be 11.7, and remember your hypotenuse should be the longest leg, and sure enough 11.7 is longer than 10 and 6, so I can be pretty confident that I have the right answer here. So why don't you guys take a minute now and solve this triangle. So you're going to be finding angle, you're going to be finding angle A and angle B again. And then you're going to be, this time, you're given side B and we're given side C. So you're going to want to find out what the measurement of side A would be. So why don't you guys pause the video, see if you can't find this to solve the triangle, and hit play when you're ready to check your answer. Okay, so let's see how you did. So you should have, to start out with angle A, I'm going to actually show you two different ways that you could solve this triangle. So we'll start by, let's say if you found angle A. To do that, this side is adjacent to the angle, and this is your hypotenuse. So the ratio that uses the adjacent and the hypotenuse is the cosine. So we would take the cosine of A equals 5 over 11. So to find A, we would take the inverse cosine of both sides, which would give us, as our answer, would give us 63 degrees approximately. So 63 degrees would be your answer for angle A. But let's say if instead you wanted to find the measure of angle B first. Well, now the hypotenuse is going to stay the same, but now side 5 is opposite that angle. So we would use the opposite and the hypotenuse. So the ratio that does that is the sine of the angle. So the sine of angle B equals the opposite, which is 5, divided by the hypotenuse, which is 11. So in this case, to find B, we would take the inverse sine. Oops, made that into an H. So the inverse sine of 5 divided by 11, which gives you 27 degrees as your answer. And sure enough, I mean, we could have subtracted this from 90, but I just wanted you to see that we could have started by either finding either of these angles, A or B, and then you can always subtract from 90 to find the measure of the other angle. And so to find side A, if you use the Pythagorean theorem here, a squared plus b squared equals c squared. Well, this time A is what we're trying to find, so we'd have a squared. Side B is the 5, so that would be plus 5 squared. And side C is the 11, so that would be 11 squared. And since 5 squared is 25, I'm going to subtract that from both sides. So I would have, well, let's just do this right now. So I'd subtract 5 squared from both sides, giving me 11 squared minus 5 squared, or 121 minus 25, gives me 96. Take the square root of both sides, and you get approximately 9.8 as your answer. So side A would be about 9.8. So there, we just solved that right triangle. Well, there you have it. That is how we solve a right triangle if we're given two sides. So hopefully after watching this video and the previous video, you feel like you've mastered this skill to be able to solve any right triangle on your own. So with that, good luck.